All right, everybody, welcome to the channel. And this is the first ever video of us crushing some IB style chemistry questions. So for today, I prepared something really special, which is Hess's Law. A lot of people have difficulties with Hess's Law, and most specifically what I like to call the algebraic method of Hess's Law. That happens when the question shows you a bunch of steps. And we know by Hess's Law that the sum of the delta H of the steps has to be equal to the delta H of our net equation right here. So when the question gives you some steps and asks for the expression of the net equation, here's what you do. There's a very simple method. Because if you add these equations, you see that they don't add exactly to the net equation. So for example, 1 mole of oxygen plus a half mole of oxygen plus 3 moles of oxygens, they will not add up to half a mole of oxygen. And if you have to worry about oxygen and flipping equations and flipping delta H's based on that, you're going to spend a lot of time, you're going to lose a lot of time and energy. So here's a really simple method for you to calculate algebraically the right expression for the delta H of the net equation, okay? So first of all, we're going to pick only one species, right? One molecule, one compound, one element per step to worry about. And here are the criteria, okay? First criteria, it has to be present in the net reaction, okay? So whatever species we pick have to be present in the net reaction. And also, preferably, it does not repeat on any other step, okay? So the first thing you're going to do is next to every single delta H, you're going to write a multiplication sign and you're going to write a parentheses. So multiplication sign, parentheses, multiplication sign, parentheses. And don't worry, we're going to fill in these parentheses soon with very specific, easy to follow criteria. So here's the deal. First, let's pick our species, okay? And they could be anywhere in the step, right? So here's the deal. Oxygen. It is present in the net equation. CO2 is not, so we cannot pick CO2. We can pick oxygen, but the problem is oxygen repeats. Oxygen repeats on the other steps. So what about carbon? Carbon is present on the net equation, and it does not repeat on any other step. So we're going to pick carbon in the first step to worry about, okay? Let's go to the second step. Well, water is not present in the net equation. Oxygen is, but it repeats on the other steps. So let's check hydrogen. Well, hydrogen is present on the net equation. So, and it does not repeat on any other steps. So we're going to pick hydrogen gas for the second step. Now going to our final and third step, we have C2H5OH, also known as ethanol. We have oxygen, CO2, and water. We cannot pick CO2 and water because they are not in the net equation, which leaves us in between oxygen and ethanol. You don't have to know this is ethanol for this question, just C2H5OH. Oxygen is present on the net equation. However, like we said, it does repeat on all the other steps. So why don't we just go ahead and pick ethanol? Let's just pick ethanol for that one, okay? Now, for the parentheses, let's start populating them like such, okay? So let's decide what sign they're going to have, positive or negative. How do you decide that? You have to ask yourself, is the species that you pick on the same side as the net equation? So for example, carbon is a reactant on the step, and it is also a reactant on the net equation. It doesn't matter. We're going to worry about the coefficient later. All that matters is they have to be on the same side, both in the step and in the net. So in this case, they are on the same side. They are both reactants. So we're going to add a positive sign to our multiplication here, okay? We're not going to change this sign because we're multiplying by a positive number. Second step, hydrogen is also a reactant. It is not a product. It is a reactant on both step 2 and the net equation. So let's put a positive sign here too. What about ethanol though? Ethanol is a reactant on step 3, and it's a product. Ethanol is a product. Sorry about that. Ethanol is a product of our net equation. So since they're on opposite sides, we're going to add a negative number here. We're going to be multiplying this by a negative number, okay? Now let's go on to the numbers we should put in these parentheses. So you just have to check, does it have the same coefficient? If it does, you put a 1. If it does not, you put the number that you have to multiply it by to make it equal to the net equation. So for example, we don't see a coefficient for carbon, so we can assume this is 1. Okay, this is safe for chemistry. If it was 0, carbon wouldn't be there. So every time there's not a coefficient there, you put a 1. It's 1 on the step and it's 2 on the net reaction. So we have to multiply this coefficient by 2. Let's go to the next one. The coefficient on the step for hydrogen is 1 and it's 3 on the net equation. So we have to multiply by 3. The coefficient of ethanol is 1 here and it's also 1 here. So we just put a 1. They have the same coefficient. So our delta H is now. So now you just assemble your delta H. It's going to be minus 394 times 2 plus, because Hess's law states that you have to add it, right? So you don't change this sign unless it's absolutely necessary. The second step is going to be minus 286. Just repeat the original times 3. And in here, we're multiplying a negative number, minus 1367, by negative 1. So that is, sorry about that, that is plus 1367. Minus times minus plus. Okay? Alternative D. Thank you so much for sticking to the end of this video. And stay tuned for the next reels and videos for us to crush some IB style chemistry questions together. See you next time. Have a good one.